We're going to hear from one of our adjunct faculty, Professor Robert Rodini, about how he turned a common mathematical game, often played in elementary school and middle school, but I've got to admit, I installed on my cell phone his game, and I'm having a blast playing it. For middle schoolers into a smartphone app, he'll explain the languages and tools that he used to create the 24 challenge, which is available on iTunes if you have an iPhone, and Google Play. I have an Android phone, so I went to Google Play to download it and install it. The app helps users sharpen their mental skills by having them choose one of two pairs of numbers and then mix addition, subtraction, multiplication, and division to make those numbers work out to 24. Professor Rodini is a former software engineer for Vanguard, Unisys, and other companies, and he'll discuss what attracted him to pursue a career in computer science. He has twice won a Unisys Achievement Award for excellence, and he was named Unisys Lead Developer. Many of you don't realize that major computer programs are not written by one person, but a team of people. So it's a team effort to write major software. In addition to teaching at our college, he teaches at Penn State, Great Valley, and Vanguard University. So, ladies and gentlemen, thank you for attending, and I give you Professor Robert Roubini.
I'm going to try this just to save my voice for the 5 p.m. showing. I see some of my teaching colleagues here, some of my students. Welcome to everybody. I'm going to tell you why I became a software engineer. I pursued that for 40 years, and why I did this 24 game and how I did it. So, does George have to activate that?
I think he has.
He has one, okay. Whoa. What was that? Oh, nice. All right, good. Stabilize. So, 24 game from middle school to the App Store. I'm a teacher in both the math and computer science department. And I want to start with my education. I'm a local guy. My family originated in South Philadelphia, but I grew up mostly in Howardtown, in Delaware County, and I attended all local schools, either in the suburbs or in Philadelphia itself. So I went to high school probably not more than 5 miles from here, and there are my school colors, red and blue. Can anybody guess what high school is, local school? It's Cardinal O'Hara High School. And then I liked the school colors so much, I went to a university that has the same colors, and guess it's here in Philadelphia. I got a bachelor's in math from the University of Pennsylvania. Then I started work, and my 2 master's degrees came from the same school. And again, it's in the area. Blue and white, well, that's someone. Yeah, okay, that's a right guess. V for Villanova. Many years ago, I got a master's degree in computer science from Villanova. And within the last 10 years, I started missing math, and I wanted to learn more math. So even though I was like the oldest student in the class, I wanted to get a master's degree in mathematics. So I went back to Villanova and got a Master's of Arts in Mathematics from Villanova. And for any of the students out there that are considering post-baccalaureate education, I have one word of advice, is to try to get your employer to pay for that degree. So my computer science degree was paid for by Burroughs, and my MA in math was paid for by Vanguard. So I didn't have to spend any money on this. I have to mention a little bit about my family dynamics. I have two brothers, an older brother and a younger brother. We're each about 4 years apart. And I never considered myself in direct competition with my older brother because 4 years is a lot. But I did see him studying all the time, getting good grades. And my mother was always sure to make sure that we did our homework and were prepared for tests. So here's an ancient picture of me and my brothers. There's Ben on the left, I'm in the middle, David on the right. Let's see. Well, some people say that we were born with the STEM gene. Because I want to show you some excerpts from my brother's LinkedIn pages. My older brother is a chief engineer for a NASA subcontractor. He still works for NASA. And he has a PhD in mechanical engineering. My younger brother is a chemist, a research chemist that works for DuPont. He also has a PhD in chemistry. So it turns out that I'm the dummy in the family. But this STEM gene, we certainly had it, but it doesn't seem to be passed on to any of our children. Because right now, none of them are pursuing what you would call a STEM career. So when I was graduating from Penn, I had to decide what I was going to do. And I came up with these possibilities. One was graduate school in math, but I've studied abstract algebra, and I came to the conclusion that's way too hard. I'm not talking about algebra 1 and algebra 2 here. I'm talking about homomorphic functions between groups, and quotient groups, and isomorphisms, and things like that. I also thought about teaching, but I didn't have any teaching certification. So that restricted my applications to private schools. I also considered actuarial science or statistics. At the time, I thought that was boring. But now I've developed a keen interest in statistical analysis because there's a big movement. It's called big data or data analytics, and it's really hot stuff, and I'm learning some statistics on my own. Coursera and edX and things like that. I also considered computer programming, and 2 of my math courses at Penn were about numerical analysis using Fortran, and I liked it. I liked the practical nature of problem solving that computer programming represents. So why not? Now, in the course of my teaching application and my programming applications, I did get 1 teaching offer and 1 computer programming offer. Literally, the programming offer paid twice the salary as the teaching offer. But we already know stuff like that. Here's a synopsis of my career. I worked for Burroughs Corporation as a systems programmer. What does a systems programmer do? That's the kind of program that involves writing operating systems, interpreters, compilers, heavy-duty stuff. But all the people I worked with, none of them had computer science. Why? There wasn't a computer science major at the time. I believe most of my colleagues were math majors, but there were some exceptions, just people who had aptitude for programming and could do it. And I worked with some really bright people at Burroughs, who conceived of a very innovative computer series, E900, E90, 900, and 1900. These are a progression of machines from a small guy to a medium-sized guy to a fairly large guy. But the goal was to make the application programs portable across these different machines. And we achieved that by the use of virtual machines. So the applications that the end user wrote were portable, and if you needed a bigger machine, we had a path for you. Burroughs had a path, an upgrade for you. Now, if you're familiar with the Java programming language, you know that it's portable across different devices precisely because because somebody has written a Java virtual machine for that device. But Burroughs was doing it in the 1970s. It's not a new idea. From there, I went to work for a startup company called Multi-Solutions. That was interesting, especially because I had to give a deposition to the Security and Exchange Commission attorney on my capabilities in writing compilers. That's a different story. I'm not going to go there. Then I went back to Unisys. Unisys is the merged Burroughs Corporation, Sperry Corporation. And in the early 1990s, Unisys wasn't doing too well. Well, the startup company did fail. And in the 1990s, Unisys wasn't doing too well. So I was trying to improve my skills and find another employer. And I did land a job at Vanguard Group. I was in their IT department for almost 17 years. And I've been teaching here at Delco since 2011. Started with computer science, and then within the last year, I started teaching a math course. So let's talk about the 24 game. You're given some numbers, and you're told you can only use the basic operation, multiplication, division, addition and subtraction, and any parentheses that you might need in order to change the operator precedence. And you have to write an expression that equals 24. So here's an example. You're given three numbers, a triple, 1, 10, and 15. So this one's not too hard. A solution would be 15, take away 1, add 10, yeah, you get 24 there. Another solution is, well, you can add 15 to 10 and then take away 1 and get the same 24. They're both acceptable. They both have to be accepted. Here's a different problem. The numbers are 8, 6, and 2. And you probably figured out that you can multiply 8 by 6 and divide that product by 2 to get 24. Here's an alternative solution. 8 divided by 2, 4 times 6 is 24. Well, let's make the 24 game just a little harder. Instead of just giving one set of numbers, which you have to compute with, let's present two sets of numbers. The trick is, one set produces a solution, but the other set doesn't produce a solution. So now it's a little more interesting. So it looks something like this. Here's two triples. You can ponder it just a short while. I'm sure you can come up with a solution. But you have to pick between those two triples. And so here is a solution. 10 take away 3, 7 plus 17 is 24. And the other triple, there's no way you can manipulate it using those operators to get 24. So it's time to show this bad boy. Let's see if I push the right buttons. Go back a screen. There. Thank you. All right, so I'm running this on my iPad too, and I have a folder that just contains 24 apps. I'm not the first person to do this. There's lots of competition out there. Mine is the one in the lower right-hand corner. I call it 24 Challenge. And so here is the home screen. Okay. So home screen on PhoneGap, this literally has to be index.html. You see 4 buttons. Here's the one that nobody ever pushes, how to play. It's the manual for the game. So here's one excerpt from one of the screens. I call this the problem screen because you can see the 2 sets of numbers. They're big wide buttons that the numbers are displayed on. And the target number is the one in the middle. It's not always 24. So this is a very simple problem. And then the next screen is the solution screen, where those numbers that you chose prior become buttons on the solution screen. you click a button. It comes down to the solution window. When you've completed your expression, you click the try button, and it evaluates your expression and tells you if you've got the answer correct or incorrect. And this is how I have to give information how the hint screen worked. It's not too important here. So what are the options for playing this? Well, I wanted some variety. So you can play with the natural numbers, the counting numbers, 1, 2, 3, so forth. You can play with small fractions. That's an alternative. It makes the game a little harder. And you can change the difficulty level. Level 1 is really simple. Level 2, a little more difficult. Level 3 is the typical presentation. And I'll talk about level 4 later. You can vary the number of problems with this slider, but I usually play very short games of just 2 problems. And then it does keep track of your prior scores, at least your top 5 scores. So here's a score, and if I wanted more details on it, I just open up a little window, and I played this one maybe just this morning. I was using the natural numbers at level 3, got 2 right, and so forth. So let's play a game. Here's our problem. Which triple, 1, 9, 15, or 3, 10, and 16? Right. So let's go with this. 1 times 9 plus 15. Oops. Now, okay, I'll clear that because it didn't. Yeah, I got it right. I want to show, so this one, as a matter of fact, it was in the presentation. I want to show just the syntax error. I have 2 pluses in a row. And it doesn't matter what I enter after that. But it tells me I have a syntax error because it doesn't know how to interpret the 2 consecutive pluses. So I have to start over. And I will enter an incorrect answer. So it tells me it's incorrect, but it also displays a correct number just to ensure the user that there is a solution to that. So just to add a little multimedia. There isn't applause built in, and if you get a top 5 score, you'll hear some applause. And one more thing I want to demonstrate. Rotates. I got that functionality for free from jQuery Mobile, which I'll talk about. Good, that part of it's over. Go back to this. Silly system. So you have to realize when I started this project, I had no training in doing development for mobile devices. I went into the project cold, and these were my personal goals. I wanted to learn smartphone programming. I didn't want to spend a lot of money. I wanted to share something, and I wanted it to look professional. And here is my self-evaluation of whether I achieved these goals. I certainly learned a lot about smartphone programming. I spent a little more money than I intended to. I definitely am sharing it because it's a free download. There's no in-game purchases, no advertising on the game. And I think it looks professional. And to increase that opinion, I set up my own company. You might have noticed it on the home screen. It's called primesorust.com. I was trying to think of a really neat math name, and I did domain searches. They were all taken. So what's wrong with Primes or Us? So version 1 of this was written as a native Android application. That means it's written in Java, and its primary tool there is the Eclipse IDE with the Android SDK. And even there's still a big learning curve, because you have to learn that Android SDK. And just like Java, it has literally thousands of APIs that you can use for graphics, for whatever. The only problem is, it was Android only. If you want to go native, that's what happens. So in version 1.2, I challenged myself to make it portable across Android and iOS. And the way to do that is to write it using HTML5, Cascading Style Sheets 3, and JavaScript. And if you do it the right way, your app will now run on all iOS devices and all Android devices. That means iPhones, iPads, Android phones, Android tablets, and it's available both on Google Play and on the iTunes App Store. I'm expecting a surge in downloads from this presentation. So if you want to find it, just type in these keywords, 24 spelled as one word, challenge, and throw in the company name, because there's all those imposters out there, different kinds of 24s. Mine's the only one that gets hints. Here are the tools that I used. First, you need a MacBook in order to run Xcode. And I did, at the time I started, I did have a MacBook laptop, but that's certainly the biggest expense, the hardware itself. I looked around for an open source WYSIWYG HTML editor. I couldn't find anything that was satisfactory. So I ended up buying a copy of Dreamweaver. It's my WYSIWYG HTML editor. I used Eclipse and a whole bunch of plugins. Eclipse is an open source IDE for lots of different languages. Xcode is Apple's version of Eclipse. I also used the Chrome browser, and right inside the Chrome browser, there's lots of developer tools. You probably never clicked on it or went there, but they're very powerful and they help me a lot. GIMP is an open source image editor. It's much like Photoshop, and so I used GIMP to create my icons, and I relied on Google search whenever I got stuck, and I did get stuck frequently. I had no support. Technologies, I mentioned HTML, CSS3, and JavaScript, but in particular, I used both jQuery and jQuery Mobile. jQuery is a JavaScript library, and jQuery Mobile is a library on top of jQuery itself that's specific for UI interactions on mobile devices. And the great thing about these two libraries is they are portable across different browsers and different versions of the same browser. And that's extremely important. And it reflects a lot of painstaking, thankless works by the developers of these libraries to ensure that your UI effects appear the same way on different devices. So kudos to the open source developers of these libraries. A PhoneGap is both a tool and an API. And I used a PhoneGap API to solve one particular problem that came up. It's also known as Cordova PhoneGap. It's very confusing because here's a technology that has two names. So let's dig into how the 24 challenge works. I'm going to explain the nature of the CAN problems, how I used recursive descent parsing. That's understanding the expression that was typed in, and during the parsing, creating a tree in memory, and then how that tree is evaluated. So all the problems that the program presents are hardwired inside of it. I have a large number of problems, and when you start a new game, I randomly select from the large number of problems, but it doesn't generate a new problem on the fly. Everything's hardwired. And the problem set is represented as a JavaScript object. So this curly brace begins the JavaScript object. This one ends the JavaScript object. And it goes on for hundreds of lines. I just show a small number of lines here to fit on the screen. So one of those lines is a problem. And you can read it from left to right. The first number represents the difficulty of the problem. The second number is the goal. It's not always 24. In this case, it's 8. The first triple here are the solution numbers. The second triple are non-solutions. And there is one canned solution. If you got the problem incorrect, this is the solution that's displayed. You want to let the user know that it's not impossible. There is a solution. Recursive descent parsing is a compiler technique that's been around forever. Parsing basically means the program understands what you've typed in. It's figured out what the numbers are, what the operators are, and the relationships between them. So while you're parsing, you have to accept all the valid expressions and reject invalid expressions. So here are 3 forms of valid expressions. And you are allowed to liberally use parentheses as long as they balance properly. These are all valid, they all have to be accepted. Invalid expressions, of course there's an infinite number of invalid expressions too. Here are 2 multiplies in a row. Here is a missing right paren, here the parens are going backwards. So basically, parsing has to detect this and give some information back to the user that it's invalid and where it's invalid. For the valid expressions, you have to build a tree. Right, so let's see what that looks like. Here is a valid expression, and here is the tree that must be built in memory. And you can see the equivalence between these two, and it's pretty clear that you have to perform this multiplication between 8 and 6 first before you perform this division by 2. So what does recursive code look like? Here is a snippet of JavaScript code. And the name of this function is parse mult expert. That's computer ease for parse multiplicative expression. Right? We want to type that all out, so we can parse mult expert. And under certain conditions, that function calls parse atom, which under its own conditions might call back on parse multiplicative expression. And that's the nature of recursion, a function calling itself either directly or in this case indirectly. It calls another function which calls back to it. And you'll notice on this line it creates one node in the tree. I call it a Q node. Q is short for rational. I need a rational node to be created at that point in the parsing. So when you press the try button in the game, if you have a valid expression, then you have a valid tree. That tree needs to be traversed and evaluated. So what does the tree look like? The leaf nodes are operands. So you can see these are leaf nodes, they're operands, they're just numbers. The non-leaf nodes are operations. Here's a non-leaf node, it's a multiply. Here's a non-leaf node, it's a divide. There's no limits on the depth of the tree. If I allowed you to type in a really long, complicated expression, my parser would still parse it, but just create a much deeper tree. Tree evaluation is also recursive, and this one is fairly simple to explain. If I were to evaluate this node, first I evaluate its left branch, and I find another operator. So I have to evaluate his left branch. I find a number there, so I'm done I know that I can't go any further. Then I evaluate his right subtree, which is a 6, and I know what to do multiplication-wise between two numbers. I just multiply them. So I've just evaluated that subtree and pruned the tree. Now the tree looks like this. And so from this node's point of view, I've evaluated its left subtree, and now I evaluate its right subtree. I know what to do now. I just replace that node by the number 24. So I prune the tree again, and I can test whether that's the desired answer or not. I encountered any number of gotchas while I was writing the program. The jQuery mobile documentation wasn't that great, and basically the developers want to write code, they don't want to write documentation, so it's not a top priority. Books and articles are always out of date. The back button on Android, I do have an Android device as my phone. It has a hardware back button as part of its user interface. And if you use it, it disrupts the wizard sequence. In other words, the forced progression from one screen to another inside the app. And it was driving me crazy to solve this problem right in JavaScript. I don't think there is a solution. But I looked in the PhoneGap API, and there was a way to intercept the use of the hardware back button, and that provided a solution for me. The HTML audio tag, browsers are supposed to support it if they claim to be HTML5 compliant, but on a lot of devices it just didn't work, so I ignored it. Testing, I have a slide coming up for all the testing that I did. I was amazed at the number of iOS icons that you have to produce. It's literally 3 times the number of Android icons. I just like, oh, another icon, oh my God. You just do it. And then I have to give some information about Apple and the iTunes store. First, you have to give money to Apple just to be considered an Apple developer. $99 a year. You have to give to that so that you can get a certificate. I'm not talking about a paper certificate. I'm talking about a digital certificate that means that you're authorized to download your app onto your test devices. So you can't make any progress unless you give them the money. And then when you think your application is ready, you have to go through a submission process to the iTunes store where Apple looks at the app. I don't know exactly what they do, but they do some security testing, and they also see if you're compliant with their user interface guidelines. And they can just reject your application, give you very little information about why it's rejected. I was fortunate. I was never rejected, but you still have to go through this approval process that takes about 6 days every time you have a new revision of the application. So if you intend to target a lot of different devices, you should really test on a lot of different physical devices. A professional test lab will look something like this. You can see they have like Noah's Ark, or at least one of everything they want to test on. My test lab looked something like this. I have 2 old iPhones, that's my Android and the iPad device. So you might say that I have done insufficient testing, but sue me, or sue my company. I wanted to release one more version of 24 Challenge. So I was racking my brain, what feature could I put in to make it the killer 24 application? I thought of making it 24i, that is, make it support imaginary numbers. Now, if you're familiar with imaginary numbers, addition and subtraction are straightforward, but multiplication and division are very difficult, and you basically have to resort to pencil and paper. And I didn't think that was going to increase the popularity of the math game. So instead, I introduced a new level with 4 operands. And that alone makes it much harder. And I also realized if I'm going to make it that hard, I don't want people frustrated. I have to give some hints how to get to the solution. So here's an example. I'll let you ponder these numbers. Now we have quadruples or quads. Rolls 24 again. One set works, the other one doesn't. Anybody have it? Do you agree that it's harder? Okay. So the solution is just 9 take away 8 is 1 times 18 gives you 18 plus 6 is 24. So the solution is coming from this quad, and this one doesn't have a solution. But I had a new problem. How to generate problems. All right, I knew the ones with the solution I could work out mentally with pen, paper, and pencil. But I was afraid if I put a quad down that I thought had no solution, that somebody might be clever enough to find a solution for it. And who knows, they might sue me or something. So what I did is I wrote a back office application that generates the random tuples and evaluates all possible expressions. Basically a brute force approach to this particular problem. And here is the output of the back office application. It looks something like this. So I got it to actually generate problems. And here's a problem, is the one we were just looking at. And here are some alternative solutions involving the same operands. So you can see, once you find a solution, there might be lots of other solutions, but there's not going to be any solution because this exhaustive search didn't find a solution for 8, 11, 15, and 9. How did I do hints? If you look at a problem line, there's no explicit indicator as which one is the solution and which one is the non-solution. But there's an implicit indication. And I realized that because I didn't want to go and edit all these hundreds and hundreds of lines. If you look at the canned solution and extract the operands, if you match those operands either against tuple 1 and tuple 2, you will find what the solution set is. Okay, you can just infer the solution set. And by doing that programmatically, when you ask for the first hint on the problem screen, what happens is it disables the non-solution. Right? Disables the non. So you should immediately click the one that's still active. And then on the solution screen, what I do is you keep clicking the hint button. All I do is I replace the canned expression where the operands appear with question marks. And if you keep asking for hints, I gradually expose the full solution. And then you still have to type that one in if you want to get credit for it. For people who are developers out there, I did write a series of blog articles to help me remember what I did, for one thing, and just to contribute to the developer community. So if you do a Google search on phone gap diaries, you'll find my blog. It's entitled Math is a Liberal Arts Major, which it is. And you'll see a screenshot from an iPhone. You can see that it's formatted a little better on an iPhone. And you can learn more if you're interested. So are there any questions?
We've got about 7 minutes, so please, if you have any questions to ask Professor Rodini, please ask him.
Have you looked into the Intel SDK that uses your HTML5 and your maybe
The Intel from Intel Corporation?
Yeah, there's an Intel application kit, like an SDK that you can actually program everything like what you're doing online, and you'll make it multi-platform.
No, I didn't look into that one in particular. The HTML5 and CSS3 approach is the one that most developers latched onto in the early days. Now I still get developer literature, and there are literally dozens of different ways that purport to create portable programs across all these devices. So I'm not from, that's probably another claim of this one, but I'm not familiar with it.
Plus, you can look at your virtual machines.
Yeah.
So you can take the code and run it on different devices virtually on.
Yeah, I mean, I was doing that with the iOS simulator and the Android simulator. So, any other questions? Yeah.
How long does it take to build this program?
To write it or to read it? I knew somebody would ask me that question, and I was trying to know how to compute the answer, because you can see I went through different versions and long learning curve. It literally took me somewhere between 300 and 500 hours. You know, so I spent a lot of time. You don't crank this out in like a day or something like that. Yeah.
But if you had to do it again,
Yeah. I mean,
everything that you learned-
now I've climbed the learning curve. I would pretty much do it again. I'm working on another app, but it's not a smartphone application. Tom, you have a question?
You had talked about your back office application to prove that certain numbers are, like if you type one in, how long what's the runtime to prove this?
Oh, it's pretty
A
fast.
few seconds.
Yeah. As a matter of fact, it can be
PC.
used. It can be used as a 24 solver. In other words, if you're playing one of the other games, or you want a high score on my game, if you had my application in front of you and you saw a problem, you could just type it. It would give you a solution like that. You know? Yeah.
You mentioned your blog. Having programmed myself, a program could be tens of thousands of lines of code, and it really is a form of symbolic logic. And without documenting or commenting your code, you can go back if you're a programmer and the next day forgot what the heck you were thinking about. So it's very important when you're programming to comment each line or blocks of lines so you can go back and remember what the heck you were doing. It's very, very deep thinking, very complicated, very abstract in many ways.
Well, not only that, Sid, it was like, yeah, I have comments in my code that help me, but like, oh, what version of GIMP was I using, you know, when I did this, or what version of this tool and that, you know, because they always want you to upgrade, and you know, it's helpful to know where you've been too.
Yeah, back in the late 1970s, I wrote video games when the resolution was really poor and the monitors were black and white. And I'd go back to the code and say, what the heck was I thinking here? That's why it's so important to comment your code. So you can go comment in English, so you can go back and remember what you were thinking.
Any other questions?
Well, let's thank Bob. Did everyone get a chance to sign the roster? Because I'm going to scan this and email it to all faculty. Everyone? Okay.